The factor definition that you see in front of you is the verb version of this, where it's writing a number as a product of its factors. We talked about what factors are for a number. We made that list over there on the board. But this is slightly different. What we did earlier were the noun versions of it, like factors of 10 or 1, 2, 5, and 10. Numbers that divide evenly into other numbers. The GCF, of course, greatest common factor, is the largest factor that a group would share. Nothing new. You've seen those before. And we've been doing factoring for these last couple days with that lab that we were working on with the algebra tiles. So we're just going to extend it a little bit more, look at it a little bit more algebraically here. Just move this down. So let's practice a couple of these GCF problems here. The difference between this and what we just spoke about, you can tell from this first example that now they include variables. So they're terms that have a variable in them, which is not going to factor into making this more difficult, I don't feel. Just a little bit different. And there are a couple of ways that we can get the GCF, but I think the best way, the most effective and preferred way by all of my students seems to be the list, just making a list. But I'm going to talk about strategies today, so you don't always have to make a list. Ideally, you could just look at these two numbers or terms and figure out what the GCF is, but we're going to get to that point. So let's start off the more basic variety here. Let's make a list. So factors of 25x. Can you give me a list of factors of 25? Lana. Well, I'm only going to put x once. So let's go with the coefficients there. The 1, what else did you say? 5, 25, and then there would also be an x there too. Okay, 5 times 5, 1 times 25, and then you would have an x that would divide evenly into 25x. Okay? How about 15xy? Same thing. Anybody create a list for me? Marco? 3, 5, 15, and x and y. Yep, we're going to list them all as separate terms here. So now once the list is laid out in front of you, it becomes pretty obvious. You're not only looking for common factors, you're looking for the greatest common factor. So numerically, what would you say the GCF is for this list, for these lists? Plural. Zoe? X is one of the common factors, yep. In fact, what we're going to do with the x is when we list this, it'll be attached to the numerical GCF. So it's going to be something x. Jake? 5x. The largest factor that they both share is 5. So our GCF between 25x and 15xy would be 5x. Because I could divide both of them by 5x. All right? Let's take a look at another one here. This next one's going to exemplify what I'm talking about in terms of needing a strategy or wanting or preferring a strategy. So 48x and 28x. I need a list for 48x. I'll start us off. 1. All right? You can just say them. I'll just write what I hear as long as it works. 6. Wait, did I hear? need two more. We have 1 times 48, 2 times 24, 4 times 12, 6 times 8. 16. A lot of factors here for 48x, right? Okay. So now we need 28x. Same thing. 1. X. Missing 1. Missing 1 number, not 7. Yeah. Think we got everything now? Okay. So now that we've compiled this list, these lists, all we're doing is searching for the GCF. What do you see? Jack? 4, yep. Anything else? X. If they have a variable they both share, we include that too. So the GCF would be considered to be 4x. All of those factors, and the largest one we could come up with would be 4. That's the way to do it. Okay? Good. All right, let's try these next two. You guys can try these ones on your own. If you want to make a list, go ahead. If you think you can do it without a list, go ahead. Just get me the GCF for these sets of numbers, please. And I'll be around to take a look. I'm curious if you guys stumble upon a strategy that makes it faster for you. When we go over this here in a minute, I want to hear what that strategy would be. More than that, the coefficient's going to be larger than that. Your note back if somebody left here. They put it back there for sure. Yeah. You just put it once. If you're taking a number times itself, you would just count that as one factor. So just put a 4 one time. Good. This one's close, Lane. You see how they both have an M and an N? Oh, okay. I couldn't tell if that was both. Okay, now. That's good. Yeah. Yeah, try that one. Yeah. Good. That's right. Try C then. Good. There's another one. Okay, so if I'm looking at factors of 40. Yeah, well, so it's 1 times 40, obviously, 2 times 20, 4 times 10, 5 times what?
5 times.
And that would be 5 times 8. So 8's a factor. See that? Okay, that's going to change your GCF. You can try C then. No, I want you to do both. Yeah, those are good. Yeah, that's good. Yeah, good. You can try that one then. Mm-hmm. Mm-hmm. So I just made the list that a lot of you were working on. And I saw some different strategies, I could tell. Some of us weren't listing them all, which again, that's fine, as long as you can tell what the GCF is from there. For letter B, with these two terms, 16S, 40ST, what did you come up with for your GCF? And you can, if you didn't have them all, they're up there in front of you, or what you had on your paper. What do you have, Lauren? 8S is correct, yeah. Some people only had 4S when I went around. This has been in all my classes so far, because I think sometimes forget that 8 is a factor of 40. We don't usually forget it on 16, but we do forget it on the 40. But I agree with Lauren. It's 8, and then they both have an S with it, so it's 8S. And then what about the next one here? The 42 and the 18, both with the MN. Faith, what do you have? 6MN is correct. All right. So now, does anybody have a way, trick, method, whatever you want to call it, that might make this a little quicker? Because I went around, I saw some of you had both of them done, and then I would go to another group, and some of those were just still working on the first one. So if you had them both done quickly, you probably have a way to kind of think about these. And that's what I want you to share to try to help others with this. We have a Cameron. So you said 16. You looked at 8 right away. Why didn't you look at 16 right away? Because that's a factor of 16. You know it doesn't go into 40, right? Okay, so then you went back and said, well, 8 does, right? And then you knew you were there. That's kind of what I was thinking of. If I'm doing this, kind of like what Cameron described, if I want to be efficient about this, I'm going to pick the smaller number, the smaller term, the numerical value, I should say. And I'm only going to list the factors of that term. So I list 16S, all right? And I go through and I start with the biggest number first and say 16. 40. Nope, so it's not a factor. Does 8 go into 40? Yep, there's my GCF. I can do it down here too. 18 and 42. I'm going to list these ones right here. Or if you don't want to list them, just go through them in your head. 18 does not go into 42. 9 does not go into 42, but 6 does. So there's your GCF. Without actually even compiling this other list. And the one up above, remember we made that long list for 48. If we would have just went here to 28x, you go 28, nope, doesn't work. 14 does not. 7 does not. 4 does. And there you go. It's just a trick. Marco? Yeah, so how would you do your list? So like 1 and 16, yep, and you kind of work your way in. Yep, 2 and 8. Yeah. Yep, and I do it either way. I don't care. Again, I don't need to see any of this stuff. If you showed me nothing and went 8S and 6MN, which some of you did, I'm fine with that as long as you know how to do it. All right, let's turn this over. Let's talk about how to factor these expressions now, not just looking for the GCF, but now actually factoring expressions, which we've already been doing. So this is going to seem a little different because we've already built to this point. We did that inquiry lab where we were moving tiles around and writing expressions, and we were getting the understanding built there. Well, we're just going to apply it here. So let's jump right into this since we do have some background. This 12x plus 48 expression, the directions say to find the GCF first. So think about the strategies we just talked about there. I bet you all could tell me the GCF right now. Well, I shouldn't say it that way. You should be able to tell me the GCF right now. What is it? 12. Yes. Now, how could I arrive at 12 so quickly? You guys just got to 12 pretty quickly. How, Lane? Exactly. Go with the smallest number. Remember I said that, this was like earlier in the period, I said, look at the smallest number. If it goes into the bigger number, you have your GCF right there. So he's right. It's not 12x because the 48 does not have an x on it. So the GCF between these two numbers is just the 12. Okay. This is what we were working on. So I would give you some tiles. I'd say, okay, here's 12x plus 48. And I would say, build a rectangle. Now, I would never give you this many tiles, but if you did, you could build a rectangle with that. And when you do that, you say, well, I built this, and I found out that I have 12 rows of certain amount of tiles. So when I say, okay, we'll write that as an expression, you say, well, 12 groups of what? Okay, now think about that. Think about if I broke this expression, or these tiles, however you want to think of it, if I broke them up into equal groups, what are we going to have in each group? How much? Emma, what are you thinking? You guys like that? It's close. Well, here's the thing. This is perfect because now I can prove something to you. If you try to do this and you write it a certain way, you can always test to see whether or not it works. How do you test it? How do you test it? Riley? How? Yeah, it doesn't equal this, right? This equals 60. Doesn't equal this. But one small change can make a huge difference here. Mara? Not, because that would be 36, or 1 plus 3 would be 4. Yeah, you get 48, but I want it to be this whole expression. We're overlooking something. I don't want to call it minor because it's pretty major. Natalie? We need an x. Okay? So now, look at this. When you check it and you distribute, you do 12 times 1x. There's your 12x. 12 times 4, there's your 48. If it factors, or if it distributes right back to where you began, then you know that it is factored in there, okay? So just like the other day, when I gave you guys some tiles and I said, okay, break them up, and I'd have one group that said, well, it looks like this. I have 12 groups of x plus 4. I've got another group that says, no, 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 no. I didn't do that. I did 6 groups. I built mine differently. I only have 6 rows or 6 equal groups. Well, for that group, what do they have in their rows? Can you figure out how much would be in each row? If you can figure this out, you're in very good shape. If you're not sure, pay attention. You'll probably get it on the next couple that we do. 6 groups of, what do you think, Lauren? 2x plus 8. We'll come back to how that is true, but that is true. Then I got another group that says, no, 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 no. I didn't do it that way. I did 4 groups. Four groups of, okay? 3x plus 12. thinking, oh, great, that's awesome. Another group's like, no, 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 hold on, hold on. I did 3 groups. 3 groups of what? Hopefully by now you're starting to see how we're coming up with these expressions inside the parentheses. And if not, we're going to explain it in a minute. 3 groups of what? Lana? Not 24, 16. And I was just about to move on and say, okay, we're good, we're good. I got one group in the corner that says, I only split it up into 2 groups. So what's in there? What are in their groups? How much? Weston? Good. Did I miss any? 1, but we don't do that. That doesn't count when you just string it, right? So how are we getting these expressions inside of these parentheses? Once I say, oh, we split it up into this many groups, or we factored out. This is like saying I factored out a 12. I factored a 2. I factored a 6, a 4, a 3, etc. How do you come up with these numbers? You guys did it. How did you get 2x plus 8? Lauren, you said 2x plus 8. How did you get that? By, yeah, you divide it by the factor that you've taken out, right? So this there. If I try it here, 12 divided by 4 is 3, so it's 3x. 48 divided by 4 is 12. 12 divided by 3 is 4. 48 divided by 3 is 16. That's how we get these terms. You're dividing it into this many equal groups. Now, there's only one of those that I really, truly want for the final answer. Does anybody know which one would be the best answer? Maybe? Cameron? 4 and 3, why? Why? That's not right. That's not the one I want. There's another one that I want. Lana? The 12. Why would you think I would want the 12, Lana? It's the, what do we call it? It's the GCF, right? So here's the rule. Always factor with the GCF first. Find that greatest common factor and use that one. Okay, Zoe? Should, yeah. You're saying when you multiply back through? Yeah, it will. Let's try. You have a question, Marco? Yeah. Like this one here? Which one were you? So my, oh, for this one, from here to here you're talking? Oh, yeah. Yeah, yeah. I agree. All right, well, let's try this. What about 6m minus 24? What's the GCF? Do that quick rule that we talked about. GCF of 6n and 24. 6, right? 6 goes into 24. So that means we're going to factor out a 6. We're going to have 6 equal groups of how much? Lane? Close. 1n minus 4, or if you just said plus and negative 4, that would have been fine too. And you don't need the 1. We talk about this all the time. If you like the 1 in front of the variable, go ahead. If you don't like it, don't put it. It doesn't matter to me. And you could have went plus a negative 4. That factors out too. Another way to do this, you could have factored out a 2 or a 3, and that would have worked. But to be fully factored, you want to use this GCF. All right, so now it's time for you to show off the skills here and factor these ones on your own. All right? 3 of these. Got it. Good. Good. Good, Jack. Those are right. Yep. So yeah, those are the GCF. Now write it as like the factored form. I covered it up. Where you have this outside the parentheses and then put the whole expression in there. Yeah, that's the GCF, right? You multiply this through, does it go back to equal that right there? Okay. 4 times 6 wouldn't be 28 though. Yeah, you have to know what each is, yeah. Do you have now? Yeah, based on what we know, that's how you would have to write that. Yeah, those are good too. Let's see, what's it say? 3, and then what's... Well, if I do... Well, you have the 3, which is right, factored out of 3, but then inside parentheses, 3 times what gives you 3? Okay, plus 3 times 33x, does that give you 33x? No, so change that second term, okay? That one is not, because a common factor there is not x, like there's not even an x on there. This place is reserved for a common factor, so see if there's any other common factor on there. That's good. That's good, yeah. Yeah, we're going to talk about how to write that. That's good. This one here, if you do 3 times 11x, you get 33x. But I also have to get a 3. So what else do I need there? 3 times what will give me the 3? Yep, just a 1, and then close the parentheses, and you're all good. All right, guys, listen up. So take a look on number 1, or letter A, rather. There are a couple of ways you could factor this. When you start looking at common factors, but I want you to find the GCF. Like I saw some people that were factoring out a 2, but 2 is not the greatest common factor, so you would have to keep factoring. What is the GCF on A? What needs factored out? Zoe? Yeah, so it's going to be 4 groups of what, Zoe? 1x plus 7. Exactly. Now, to get your GCF, did anybody just look at the 4 and say, does it go into 28? There it is. All right. Same thing on B. What's the factored version of this? Natalie? Yeah, that one was kind of like sneaky. Like it's I don't think it's that difficult, but a lot of people were writing. I have like x plus 11 people were writing because we always think the variable has to come first. I had other people that reversed it and wrote 33x plus 3. So then they did 3 and then 11x plus 1. That's fine. That works. But the problem here is on C. What's the issue with C? What do you run into here, Emerson? Yeah, you can't factor it. Why not? Besides what? 1. Now, if you can only find 1 as the common factor, then in our mind, we cannot factor that. So what a lot of people were doing was this. And I would say that's fine for now. But here's what I would prefer. That's technically not even factoring it. It's just the same expression written all over again. So what you would say is cannot be factored, or you could just write the initials, CBF. That's universal in my mind for cannot be factored. That's what you're telling me. Okay? All right, we're going to finish out. I got this little closure slip. Let's do this. Drop it off in the box there on your way out. Those back, please. Here, there's 2 extra there. I'll just send it for that group. 1, 2, 2 more. There you go. Is there 4 there, Lauren? Check those, Riley. It might be. Take 1 back here. I think there's 3. 1, 2, 3. 1 more, Jack. Yeah, this is for you. If I can separate him. There you go. Okay.